Hi everyone, so today we're going to learn about dissociation of acids and strengths of acids. So if you can turn with me to your theory book to page 88. Okay, so let's start. So what are we learning today? We are learning about dissociations of acids, okay, and we are also learning about strength of acids. What is our success criteria for today? At the end of the lesson, you should be able to define acids through the breaking down of acidic molecules to form hydrogen ions. So this is the dissociation process that we're talking about. And also, you should be able to distinguish between strong and weak acids in terms of their extent of ionization. So this is in terms of how much of the molecules can be turned into hydrogen ions, can be broken down to form hydrogen ions. Okay, so let's start. All right, so our context that we're looking at, our example is hydrogen chloride gas. This is the same molecule that we saw at the beginning of the chapter. So before hydrogen chloride gas was dissolved in water, it exists as a molecule. Okay, so as a molecule, there are no ions. So in this situation, it is a molecule, and hence there are absence of hydrogen ions. Right, because there is an absence of hydrogen ions, right? Because there is an absence of hydrogen ions. Let me just get that right. Because there's an absence of hydrogen ions, it is therefore not acidic. Okay, so how can it become acidic is when water is added in. So when the molecule is placed into the presence of water, the water will cause a process called dissociation to take place. So what is dissociation? If you look at the diagram over here, dissociation is a process in which the molecule is broken down into its ions, um, and in the case of acids, it's in the presence of water, right? It's in the presence of water, but dissociation is basically the idea where the molecule is broken down into ions. And sometimes you also hear another word being mentioned quite often. You may also hear of the word ionization. So the idea is similar, is that a molecule has been turned into ions, right? And so over here, once dissociation of the molecule has taken place, you would notice that hydrogen ions are created. Only when hydrogen ions are created, it will then have acidic properties. Okay, so if you recall our previous lesson, we talked about pH, right? We talked about pH, and pH is a measure of acidity. So, how acidic a substance is, and I can only measure if a substance is acidic by if I can only measure if a substance is acidic provided it has hydrogen ions. So H plus ions must be present. Hence, with this, you can quickly see that before it has been dissolved in ion, before it was dissolved in water, there was no hydrogen ions present. But after it has been dissolved in water, hydrogen ions are formed. Okay, so before that, there was no acidic properties, but after that, it has acidic properties. Okay, so this is a very important fact that you must know, and please take note that this can only happen in the presence of water. All right, so what about other solvents? Some common solvents that you may come across could be things like oil or methyl benzene, which you may see in the last lesson. Sorry, methyl benzene. These are what we call organic solvents. Organic solvents are not able to cause an as are not able to cause our molecules to be ionized and dissociated to form hydrogen ions. So if you see over here, if I were to place hydrogen chloride molecule into different solvents, I will have different effects. Of course, if I didn't put it in any solvent at all, it will remain undissolved, it will remain as a molecule. If I place it in water, dissociation process will take place, and hence hydrogen ions are formed. Okay, so this will cause it to be acidic. And lastly, if it is placed in oil or in organic solvents like methyl benzene, the molecule will also not dissociate and it will remain as a molecule. Hence, if I were to place, uh, let's say, a dry universal indicator into this mixture, it will not be able to detect any change in pH at all. So that dry universal indicator paper should remain green. Okay, so please take note that the dissociation process only happens provided water is present. So this is a very, very important fact. Okay, so um, yeah, this is just a repeat again that water is very, very necessary for dissociation to take place. So water is important in our learning of acids. Okay, because I need hydrogen ions to be formed. Only when hydrogen ions are formed, then a substance is considered acidic. All right. So next portion, next portion that we're learning about is called strength of acid. So what is strength of acid? Strength of acid depends on whether the molecule has been dissociated or not. So how strong an acid is in terms of strength, of course, I can have acids being called strong acid or weak acid. Okay, but how do we determine whether an acid is strong or weak? It really depends on whether the molecule is able to dissociate completely in water or not. Okay, so if you look at this picture over here, on the left hand side we have one in which an acidic molecule, the molecule was dissociated completely. So when we say completely, we are taking it that is 100% dissociated. So there are no groupings of any particles together at all. So everything has been broken apart, and in this case, we can see that our yellow ones are our H plus ions, and then the red one could be, in this case, our negatively charged ion. Okay, so when in a situation where the acid is 100% dissociated, we call this a strong acid. But on the right hand side over here, you see that sometimes the acid molecules only dissociate partially. Okay, they only dissociate partially, meaning to say a portion of it has been dissociated to form ions, whereas the rest of them, okay, whereas the rest of them, things like all this, these are still molecules. So when I have partial dissociation, we call this a weak acid. That's why if I were to have you describe what is a strong acid or weak acid, our idea here will be what is the extent of ionization. Sorry. What is the extent of ionization? Okay, so for the strong acid, it is 100%. For the weak acid, it will be less than 100%. All right, so going by that, you would be able to see that when I have a strong acid, there will be a lot more hydrogen ions being formed. Right? In the case of strong acids, there will be more H plus ions present because more of the molecule was broken down to form hydrogen ions. Whereas for the weak acids case, there should be lesser H plus ions formed because it was only partially dissociated. So what how does that impact the pH value of the solution then? So for the strong acid, it should usually result in a lower pH because there are more hydrogen ions present. Whereas for the weak acid, it will usually result in a higher pH because there are lesser hydrogen ions present. So for the strong acid, we are usually looking at values of about maybe 1 to 2, pH 1 to 2. For weak acids, we will usually be looking at values about maybe 4 to 6. Okay, so this will show you what is the relationship between the extent of ionization to the concentration of hydrogen ions and therefore leading to the the pH value of the solution. So some of you may be wondering what are some examples of strong acids. So you can see over here, I've got hydrochloric acid, nitric acid, and sulfuric acid. Okay, these are examples of strong acids. For weak acids, we've got things like carbonic acid and ethanoic acid. So this is the acid that I see mainly in foods. All right, mainly in foods. So this is our carbonic acid in soft drinks. This is vinegar. Of course, if we look at citric fruits like our lemons, oranges, even apples and all that, all those fruits contains acids, they would fall under the weak acid category. Okay, so what have we learned today? We've learned about dissociation of acids, which requires water in order for hydrogen ions to be formed. We've also learned about strengths of acids, and this is this depends on the extent of ionization of the acid to form hydrogen ions. So please continue to with the rest of the lesson package. Please continue with the rest of the lesson package and finish up the review questions in next page. Right, that's it.